as long as you're on board to work. Okay, we have to do so many things today. I bit off more than I can chew. So we're going to have to go ahead and go over these math workshops. And then we're going to go over our notes. I'm not going to check the homework quite yet. In fact, first period, I never even got to it. Might have to wait till tomorrow with you as well. There's a checkpoint today. There's also a perfect squares practice quiz on 1 through 16. So humor me. We'll start with the ones where you started to forget. What is 12 squared?
144.
13 squared?
169.
14 squared?
196.
15 squared?
225.
16 squared?
264.
256. 16 squared is 256. You're going to have a minute, and that's coming up later on during class. We're going to put this practice one in the homework category. The for real one is happening on Friday. We're putting it in the 60. There will be 25, because we're doing 1 through 25. It'll be 25 points in that 60% category. So just so you know all the things. And if we're being full disclosure today, I mean straight up full disclosure yesterday, and I know you're like, Miss Trump, we just took a test. And I'm so sorry. This is just how Algebra 2 Trig goes. We just started 2.1 yesterday. We finished all of 2.1. And we're going to do 2.2 today. And there is a quiz on 2.1 and 2.2 on Thursday. So just so you know, everybody knows all the things. Just so everyone knows everything. Okay, I'm looking for a volunteer for the number 4 in the bell ringer questions. Yes, Jack. So with a fast hand.
H squared plus 7h minus 49.
Okay, you got the h squared. What about the minus 7h? And then the plus 7h? And then the minus 49? And then the minus 7h and the plus 7h end up canceling out. So we end up with just h squared minus 49. Hopefully you realize the outer and the inner were going to cancel out in your head. So you just put h squared minus 49. But I'm never going to count off because you showed the steps. I was just trying to get faster by not showing steps. Okay, Jax, redeem yourself and fix number 5. Can you do that, or you want me to give it to table 2? Table 2. He's nervous about foiling now. Can you help us?
I got y squared.
And then what?
That's all I know. I think the rest of it's
I got y squared minus 4.
Okay, it should be y squared minus 1. Yes, y squared for the first. The outer is plus 1y. The inner is minus 1y. So that plus 1y, minus 1y, they do cancel out. But that last negative 1 is not going to cancel out. Are there any questions on 4 or 5? Nick, you can have a point since you did save the day. Okay, so that's review with foiling, but 6, 7, and 8 come directly from what we were discussing yesterday. Thankfully, you don't have to list domain and range. You don't have to say 1 to 1, on to, neither or both. You just have to say function, not a function. Yes, table 5.
number 6 is a function.
Function. And you can have a point for that. Number 7, table 4. Not a function. Can you tell me why? It is not a function, and she can have a point for that. Can someone tell me why it's not a function? Yes, ma'am.
There are 2 8s in the
Okay, so the 8 going to 2 and the 8 going to 3 is the issue as to why it's not a function. Because 8 is being mapped to 2 different things. We can't have our input has to go to only one output. The fact that it has 2 different outputs is like that vending machine issue again. Are you getting chips or are you getting candy? I don't know. So that's why it's not a function. Tylen said the issue was with the 3s. That's a different thing. What did we talk about yesterday? So she's right. There is an issue because those 3s are repeated. What was that? What's that called? 1 to 1, on to, neither, both. On to was that every range had a match. And everybody in the range seems to have a match. There's nobody who seems high and dry. And then now we're just guessing. If someone can explain. Well, yeah, it's gonna be, well, we don't even have to normally decide it because it's not a function. Because we have 5 going to 3, and we have 8 going to 3. My arrow's bad. Because we have 5 going to 3, and we have 8 going to 3, it is not on to. I mean, 1 to 1. Jeez Louise, now I'm saying Nick's own words. One guy going to one other guy It's not happening. We have 2 guys going to the same guy. It's not 1-to-1. But Miss Compton made that way too deep, because if it's not a function, you don't have to put any of that anyway. Okay, and then number 8, yes, table 5.
Is a function.
Yes, and you can have a point for that. Okay, looking at our notes from yesterday. Looking at our notes from yesterday. I need to fix something because, let's face it, I'm not perfect. I told you my brain was on the weekend the other day. It finally came to me. Okay, the other day I told you I wasn't sure what to put in the top blank. Well, clearly I can't read, because if I was reading the very top blank of the vocab on the very first page of the Chapter 2 notes, it should be the word relation. Because, duh, we're talking about relations and functions. So that missing vocab term is relations. Relation. And you're like, Ms. Compton, why are you fixing that? Because as a department, we've been emailing around. We're doing 2 different tests in Chapter 2. We're emailing around that first test in Chapter 2. And doggone it if the first bit isn't vocab. And doggone it if that's not one of the blanks. And you were going to have the wrong word to put in. So just, you might want to make a start of yourself. I know that's on the Chapter 2 test. In fact, I'm pretty sure all 4 of them are on that Chapter 2. And I'm going to call it the mid-test. Just so you've been warned. Okay, I know you've got function, not a function down. I know you've got domain and range down. As a reminder, because this was new to us, 1-to-1, 1 in domain is going to 1 in range. If 1 is going to D, nobody else can go to D. Nobody else can. 1-to-1 is not as easy to spot to me as onto. Onto is when someone in the range doesn't have a match. For instance, C doesn't have a match. So this is not an onto function. And both is the easiest to spot because everybody, it's not Noah's Ark. They all got a pair. Pair. Everyone's got a match and only one match. Okay, so we talked about function, not a function. We talked about that vertical line test. We even talked about evaluating a function. And I joked that if it said epic cupcake, then everywhere you saw the letter X, you would put in the word cupcake. So hopefully last night you actually did 4 problems we discussed. If not, again, I think I ramble and we do so much today that I don't get to check it today. So Justice is going to make a note to himself. He has got to have 5, 6, 7, and 8 done by tomorrow. If he didn't make the note last night, he's got to have it done by tomorrow. Okay, so again, we're having a quiz on Thursday. That's all of 2-1. That's one of the 2 sections on the quiz. Okay, moving along to what I think is a more familiar section to you, maybe. I don't know. Relations that have straight line graphs are called linear relations, Miss Compton. Relations. So our first blank is linear relations. Relations that are not linear are called, what are they called? Nonlinear, and your group can have a point. They're called nonlinear relations. An equation such as x plus y equals 5 is called a linear equation. A linear equation and here are the rules about it. It has no operations other than addition, subtraction, and multiplication of a variable by a constant. So, and then it says the variables may not be multiplied together or appear in the denominator. So, x, y equals 2, that's not linear. Or 1 over x equals 3, that's not linear. It does not have variables multiplied together, and it does not have variables appear in the denominator. It also does not contain variables with exponents other than 1. So x squared plus y equals 7. That's not linear either. And then last but not least, the last sentence is the one that I think everyone knows. The graph of a linear equation is always a the graph is a line. And you can have a point to one. Making life way too deep, Tipper. Way too deep. Linear function has a line. Okay, I'm going to skip the review characteristics because we did some examples on the side. We have some examples down here. This one's not linear because of that 2. This one's not linear because of that square root. This one's not linear because they're multiplying x and y together. This one's not linear because they're dividing by x. There's an issue in each of those. Don't worry, you're about to have to practice. A linear function is a function with ordered pairs that satisfy a linear equation. So clearly Ms. Compton was just showing you what you're going to do now. Help me identify, is this a linear function? And if it's not, you better explain why not. Number 1, any takers? It is a linear function. I heard it first from Angel, so she can have the point. Okay, then we get to number 2. And if you can explain, you can get the point. And I'm going to say due to x in the denominator. I'm going to give it to 2 and 3. Or you might put not a linear function due to x in the fraction. This is not English class. You can use other words than me.
So if the x wasn't
If it was,
in the denominator, it would be correct?
well, x doesn't really, if it was, well, yeah, it'll still my joy because it's about to come out. Well, technically, if it's in the numerator, like 2x over 3, it's really the same thing as 2/3 x. So really, it's not involved in the fraction, technically. And again, you and Angel are trying to steal my joy. Give it one more example and I'll steal it there. No. Number 5. Number 5 and we'll be there. Okay, let's go to number 3. It's on the back. Number 3, linear function, not a linear function. Why is it not a linear function? Okay, every group can have a point. Jax. Never mind, Jax. It's a hard one. I was going to be like, Jax, your group needs to handle number 4. And then I looked at number 4, and it's kind of a doozy.
It's not a function. Because it needs an x, only has y. Or it could be a function you could just grab. So the x would just be 0, right?
It could be a line.
Yeah, it could be a line. Because your x would be equal to 0.
So, and then when we get done with this, will you fix the wheels on table 3? Because
What happened to it?
it's having we'll look at it later. I just noticed it, and I got distracted. Okay, so Angel is mad at the lack of an x, but really it's 0x plus 19. She knows how to graph that. She knows she puts her intercept at 0. She can't count a slope of 0. She puts her intercept at 19. It's got a slope of 0, so it is just that straight line at 19. So it is a function. That one is a linear function. It was definitely a trick. And then we get to number 5, which is also tricky.
It's a function.
It is linear, and this is what people are nodding, but it has a fraction. I thought we were mad at fractions.
I know, but the x is on x.
Okay. And then someone last period said it like this. It's y equals mx plus b, but they swapped around the mx and the b. So it was y equals 8 minus 3/4 x. If we rearrange this equation, we would have y equals negative 3/4 x plus 8. Hey, Jax knows how to graph that. He puts his intercept at 8. He knows how to count the slope of negative 3/4. If you ever get confused and you're not sure, if you'll rearrange it into y equals mx plus b, and it looks like normal, it is a linear function. if you rearrange it and it looks cray-cray, then it's not a linear function. Cannot believe I just said cray-cray, but it came on out anyway. Moving on. Number 6.
Not linear.
It's not a function. Why?
Because the x is
Q.
Okay. And I'm just going to put due to exponent. If you want to use more words, you can. Okay, so that part seems pretty easy. So part of 2-2 is, can you identify linear or nonlinear? And then part of 2-2 is the thing I told you the other day that I forgave you, even though you forgot what standard form was. I don't forgive you anymore. It's over now. I need you to know. Standard form is ax plus by equals c. A, b, and c are integers, and they have a greatest common factor of 1. Okay, so we're going to have to rearrange our equation to put it in this form with the x and y on one side, the number on the other, and identify a, b, and c. So for instance, on number 1, if I subtract both sides by 4y, I would have 2x minus 4y equals negative 1. So my a is 2, my b is negative 4, and my y is negative 1. That's it. Are there any questions on number 1 that I need someone to rearrange number 2 and tell me what the a, b, and c are?
Add 9.
Number 2, not 3. Did you do the x term, the y term, and then the equals the number? Okay, I agree with that. And then what's my a, b, and c?
Negative 2.
It does look like that, which is why you need to make a note to yourself, because I said it out loud the other day, but you didn't write it down then. Maybe now you'll write it down and remember. There are some rules with standard form. A is a, what does the symbol mean?
natural.
Yeah, so if you, or there are some who still cannot classify, and bless them, thank God that test is over and we don't have to do that anymore. So if you need to make a note to yourself, what we're saying is A is not a fraction and not negative. We cannot have A be a fraction, we cannot have A be negative. We need this to be a pretty nice number. We have an issue on yours. A is negative. So we're going to have to multiply everybody by negative 1 and change it to 2x minus 5y equals negative 3. And now we can identify our a, b, and c. What are our a, b, and c? Perfect. There are not many problems I'm leaving for you to deal with, but number 3 is for you. If you want to do it real quickly now, you can. If you just want to save it for homework, that's fine too. I'm going to move on to number 4. Why am I going to help you with number 4? Gosh, you and the fractions. Someone said, can we change it to decimals? The 3/4 would be 0.75. That's fine. The 2/3 is where our issue is going to happen because that's 0.666. So then Justice rounds to 0.67, and then his answer is a little off. So no, we're not going to do that. But I can kill the fraction in just one giant step. What number can I multiply by? That's going to, Ellie, you get your point. You were like half a second too late, Angel. She was like, it was close. If we multiply everybody by 12, the denominators are going to end up going away. And we'll be happy again. But for now, we'll do 3 times 12 is 36. So we have 36 over 4y. 12 times 2 is 24. So 24 over 3x. And then 5 times 12 is 60. If you need to draw the arrows of you distributing, that's not a bad idea. Daniel likes to do math in his head. It's not a bad thing. So I realize Daniel can do that in his head. If he wants to jump straight to 9y equals 8x plus 80, I'm not going to be mad at him. Okay, and then we have a tiny, tiny issue. What's our issue? Yes, so we end up with negative 8x plus 9y equals 60. So again, we end up having to multiply everybody by negative 1. So we can have 8x minus 9y equals negative 60. And I know from here Daniel can identify his A is 8, his B is negative 9, his C is negative 60. Or maybe Daniel's smart enough in his head, he doesn't actually show me the step where he multiplies by negative 1. He just knows to change everyone's sign so that A is positive. But let's be honest, Daniel's overcomplicating this problem. He could have fixed it to begin with. How could Daniel have made this problem easier to begin with? Does anyone know for 2 points? Yes, dear.
I'm up to number 4, right?
Yeah, how could he have made this problem easier to begin with? I wish I didn't have to do this negative. And that's how you get 2 points right there. If Nick is smart enough in his head, he realizes, hey, forget the fractions. No matter what happens, when I move that x over, it's going to be negative. So since I'm already multiplying by 12, why not multiply by negative 12? If Paige does that to begin with, she's not going to have to do this mumbo-jumbo here at the end. It's just a thought. I'm getting real deep. Okay, number 6 is your problem. So you can circle it because I need you to handle it. Number 5 I will help you with. Why am I not leaving number 5 up to you? There's no x. So if you had to tell me the A, B, and C right now, what would you say? A is 0, B is, and then C is. Okay, and that is actually correct, but I was afraid you were going to say A was 1. So if we rearrange it, we have 5y equals 9, but there are no x's, so I'm just going to put in 0x because it makes me feel better. So now for sure I see 0, 5, and 9. I just don't want Daniel to, I moved the 9 over, so it was 5y equals 9. And then there were no x's, so I just wrote 0x to help me. So I would put 0, 5, and 9. I just don't want Daniel, since there are no x's, to be tempted to put that A is 1. That's why we did this one. Okay, and then that seems pretty easy. Last seems pretty good. We're almost done today. We only got a couple examples left. But here's the problem. Miss Conley gave you like a 20-page thing, right? You knew she was going to mess up on something, right? The next one is not our, I know it says 2-3, but we're not doing that today. We're actually doing the back, the last page of the 2-2. So basically, this page, if you wanted to pull it out and hole punch it, I've hole punched it wrong. This is our next problem. My bad. There was bound to be a mistake somewhere. Okay. So I'm sorry for that. This is still technically 2.2 notes if you want to like write that at the top to help your brain or whatever. So it says that, and that's our last learning target today, something about graphing and at linear equation using the intercepts. Nick knows how to graph this. He puts his intercept at 8. He counts that slope. I know he can graph it when it's in this form. He's seen y equals mx plus b pretty much his whole life. But on number 2 in standard form, if Nick's going to rearrange it to put it in y equals mx plus b, my God, Nick is slowing down his life. And then especially on number 3, that's going to take a few minutes. So Nick's not going to do that. We have a faster way to get 2 points, connect the dots, and make our life so much easier. So, if you're looking for an x-intercept, what you need to do is plug in 0 for y. That makes sense. X-intercepts happen when y is 0, so plug in a 0 for y. Similarly, if you're looking for a y-intercept, just plug in a 0 for x. Seems too simple, but I swear it's going to make our life so much easier. So I need to know the y-intercept and the x-intercept on number 1. What is, yes, Jax? It is, which one's which?
X is 2, Y is 2.
Okay, so I think everyone knew the b was going to work. So when we plug in a 0, we got to have y equals 8. So that makes sense for the y-intercept. So let me show that for those of us who are like, what are you doing, Miss Compton? So for the y-intercept, we plug in a 0 for x, and we end up getting y equals 8. That's how Jax got the 8. Similarly, if we plug in a 0 for y, you end up with negative 8 equals negative 4 over 2, so 2 equals x. But again, hopefully Jax did this in his head, this rearranging. If he plugs in 0 here and rearranges, or plugs in 0 there and rearranges, I'm hoping he does it in his head. Okay, so we go to our x-intercepts at 2, our y-intercept is at 8, and then hopefully you're a great connect the daughter. I tend to need something straight. I'll try my best though. That was not my best line, let me tell you. We try to connect the dots. We're done. Now again, I know that Jax could have graphed it probably equally as fast as it was in y equals mx plus b. But on number 2, this method should definitely help. So on number 2, I need to know my y-intercept, and I need to know my x-intercept. And you can have a point. Okay, the y-intercept is at 4, the x-intercept is at 6, and it's actually super easy when it's in standard form, because, for instance, with the y-intercept, we're saying x is 0, so cover up the x piece, we would have 3y equals 12, or y equals 4. That's pretty easy. We had 3y equals 12, so y equals 4. Y-intercept was pretty easy. X-intercept just as easy. Cover up the y piece, we would have 2x equals 12, so x equals 6. Holy moly, that was easy. That was way faster than us rearranging that equation. And now I just have to put my x-intercept is at 6, my y-intercept is at 4. I connect those two dots. And meanwhile, Nick would still be trying to rearrange his equation to y equals mx plus b. And I'm already done and I've graphed it. One last one, and I swear we're done. I would say it's yours to handle on your own, but you'll be mad at it, so I won't let you do it. First, it's probably best to move that 6 over and have 3x minus 4y equals 21. That's my first suggestion. Can someone tell me the x and y intercept? And I want the fraction, not the decimal. I got the x with 7. Okay. Again, for the x, it was 3x equals 21, so x equals 7. That one's pretty easy. This one, we end up with 21 over negative 4. That's not as easy. Okay, I guess I do need that decimal. Is it 5 point something? Negative 5 point something? Okay, so I'm going to go, move my paper over. I'm going to go somewhere between 5 and 6, put a dot for that y-intercept. Doesn't have to be perfect. Somewhere between 5 and 6. I put a dot for my x-intercept. I connect the dots. And hot dog, we're done. So again, today, we had to identify linear and nonlinear. We had to identify the A, B, and C in standard form. And then last but not least, we're graphing. But we're graphing just using the intercepts rather than having to rewrite everything into slope-intercept form. Are there any questions about this? Okay, and then let's go ahead and clear off your desk. You don't need anything except a pencil.